All right, everyone. So welcome to the OpenJ9 MicroJIT contribution meeting for the 13th of August. It's great to see a number of people attending, especially some returning faces. So thank you to everyone who has been helping with the contribution effort, and to those who've been commenting on the issue as well. So I've got the agenda, the loose agenda up on the screen, but it's probably best that I turn it over to Scott to start with, just to provide a general update, and we can get into specifics on those different areas I listed, since they were areas where we had outstanding action items last.
All right, so thank you, Andrew. I'd like to give a quick shout out to Marius. He came through early last week with an email that gave me kind of an in-depth rundown of where the patching and generation of the trampoline happens for TR, for GCR code, and kind of how it works at a fairly fine leveled granularity of detail. So we are moving along fairly quickly with GCR. I have to make some templates and make sure some things are available statically based off of the start PC. I've been adding a few things to the persistent JITted body info, guarded by a define for whether we're compiling with MicroJIT or not, so that we can get some values that would usually be in the IL tree out of MicroJIT. I don't know if we want to, at any point in time, convert the storing of that in the IL tree into the persistent body info later, just to reduce code duplication. Anyway, that's where we are with GCR. So GCR is going along fine, no roadblocks yet. For profiling, I've been kind of thinking it over in my head, and I remember in one of the slides, or maybe it was the video on JProfiling, there was a mention about how you could drastically reduce the number of counts, or the amount of counting you had to do, by putting counts on or not putting counts, and instead calculating counts for the hot path when you're doing when you're looking into the data structure. I was wondering if anyone had any ideas on how we could do that with a relatively low number of calls before we get into JITting, given that MicroJIT is going to be working on the order of 10 to 20 calls before it starts.
Well, I'm not quite sure what your metric of calls is. Those kinds of implementations are usually done with a spanning tree across a control flow graph. So to minimize it, you would be basically doing an implementation of work that was presented, some theory that was first presented by Newth, with a practical application that was presented in a paper by Laris and Ball in the mid-90s on how to do this profiling efficiently. And it basically just comes down to, you build a control flow graph, and you do a weighted spanning tree where you're going to maximize the frequency of the edges that's included in the spanning tree. That can be done iteratively, but there is some complexity to it. So I'm not quite sure what your call metric is, or if the iteration would also be part of your call metric, because you would have to build some notion of a control flow graph and process it.
Right. So when I was digging through those materials, and I believe that referenced the papers, but I haven't had a chance to read the papers yet, they were talking about how on the hot path, they weren't including the count. They were only counting the other paths on the control flow graph. And I imagine that finding the hot path must be using the data from the iProfiler. And so this is what I mean by the invocation count, is when we go to compile, if MicroJIT has only let the method run 10 or 20 times, I don't know exactly how much profile data we'll get on the hot path through a given node in the control flow graph. And I haven't gotten into the data structures, or specifically how they're recalculating the number of times you've gone through the hop path using just like the number of times you've entered and exited, and the rest of the information in the graph that is deliberately trying to minimize the number of operations performed on it. I imagine that's fairly complex. So I was wondering more specifically if I'm going to have enough profiling information, because I imagine it has to be something from the iProfiler that's allowing the J profiler to figure out which edge is going to be the hot edge coming out of a node. I'm wondering if I'm going to have enough profiling data to get that right. And if not, is it like what would be the correct thing to do, or probably a good first attempt for trying to get profiling data that doesn't trigger too many counts?
Right. So I think that even if you've only run it 10 or 20 times, if we have processed the iProfiling data at the point where the compile runs, that would be enough to pick a path, right? Like the thing about it is that the path doesn't have to be 100% correct. It just has to be it has to be a best guess. And if you get it wrong, you pay a slightly higher profiling cost. So it's going to be better than counting every path. And it may not be completely optimal if the limited profile that you have isn't truly reflective of what's happening, but it's likely to be somewhere between the best case and the worst case scenario. So deriving the equations for the various counters can actually be done as part of building the spanning tree. There's an implementation in the the J9 frequency profiler. There's actually an implementation there that uses the J9 CFG and does a spanning tree construction. And while it's doing that single pass, it also builds the derived counter equations. And it turns out that the derived counter equations are simpler than one would think just on first blush, because every counter that you place in the program, like so if you want to calculate the frequency of a given block, the equation will include each counter in the program at most once, either as an addition or a subtraction. So it's actually not as bad as you think to do some of those calculations.
Okay, so it sounds like there's a lot of supporting infrastructure there. Given that I have a CFG that's gonna and some profiling data that might be able to create that spanning tree more or less for me, assuming that I can add in whatever additional infrastructure is needed to get that without an IL tree when identifying the method being compiled as a MicroJIT compilation.
Right. So there's an example. There is some code in J9 estimate code size where we build a control flow graph while running a bytecode walker, and we aren't actually generating full trees. We just generate CFG nodes and the minimum representation needed to have the CFG. We don't actually build all of the internal stuff. So that may be a place that you could look as a starting point for where you could see how to potentially build a CFG that you could use for just doing the profile placement. Alternatively, if you had another node that had an API that looked like a J9 CFG, then the code in the frequency J9 in the J profiling frequency implementation should be reusable. It doesn't do anything really crazy. It's just using successor and predecessor and exception successor and exception predecessor as part of how to derive the counter placement. So I think I think that you can probably leverage some of that. I can try and send you some more pointers to that code after the meeting. So
yeah, that's very helpful. Thank you.
Okay, I'll send you those pointers, and then if you have a read of the Laris and Ball paper and look at the implementation that I'll point you at for where we're doing the placement and where we're where we build a CFG. I think that should get you a good way towards having an idea how you might be able to do it.
Perfect. If you have a link to that Larson ball paper, that'd be great, because just trying to very quickly Google search for it seems to be a little less. There seems to be something in weightlifting called a Lars ball, and that just what to do.
Okay, yeah. I think I have a copy of it that I can pass to you. Yeah, it was published mid-90s, so it's one of those image, every page scanned as an image type PDFs, but I think I have one of those. I'll have a look for it after the call.
All right, perfect. All right, so next on linkage, we actually bumped into an error, or it was a fairly silent bug in kind of the internal development branch for MicroJIT, based off of trying to figure out the size of various arguments that are passed on the stack, whether they're passed on the stack when the interpreter is there, or even just saving them on the stack and saving the space for them on the stack during JITted code. So just figuring out where on the stack, in the stack frame before us, where the argument space is saved on the stack, figuring out the sizes of various arguments, because some of the category 2 data types, or rather the category 2 data types, can take a single slot on the stack for AMD 64. So I'm wondering if there's any movement on the IBM side for trying to, I know we talked about in the first meeting, getting some of the architecture-specific things that don't reference specific registers and aren't direct to the creation of IL trees, kind of pulled out into something generic that uses indexes rather than TR register values and things like that. Because I think the problem was we had assumed the last category 2 used one slot, and that seemed to be working and getting correct results. But then when we moved on to some other methods that had an intermix of category 1 and category 2 arguments, it seemed like it was the first and not the last category 2 item that was only taking up one slot instead of 2 on the stack.
Right. So I don't think there has been a lot of movement on that. We've had a pretty busy couple of weeks, and there's a lot of stuff piling up on our side that's making it a bit slower to get to that. Daryl,
because you've got that milestone release coming up soon, right?
There's milestone releases coming up. There's been, a number of things that have been going on that have kind of diverted the team's attention. So Daryl Meyer is was heavily involved in the original design of the code generator, especially the x86 code generator. So he's not on the call today because I believe he's on vacation. I think probably the best thing that I can do is to try and connect with him when he's back and see what we can do. We may have to have a discussion with you offline about how we can divide the work up, because I think if we bottleneck it all on the IBM teams, it may take a while before we can get to it. But if we can do it more collaboratively, we might be able to get it done faster, because we don't have to do all of it. We can kind of point you at the right places and then help with the tricky bits kind of thing, which just reduces the amount of time it takes for us. So if you're open to that, I'll take it to send an email to Daryl and CCU to say that we're looking at doing this, and can we sort of try and collaborate, figure out what the right sequence of things to do is.
All right, that sounds great. Okay. I believe Harpreet is on the call. And I think that one of the things she's going to be looking at is kind of extracting the bits of MicroJIT that are architecture or possibly runtime independent out. So that might be a good place for her to start on that research eventually, if that's a thing that she's still interested in. I know between her and myself, we're still trying to divvy up which parts of the project for future work are going to go in whose PhD. But that sounds like an interesting thing if she plans to go down that route of kind of abstracting the idea of MicroJIT out of the implementation for AMD 64.
Okay, yeah. Hello everyone, I am Harpreet. So whatever you are discussing makes sense to me. So we can discuss later after a call or maybe in a day or two, Scott, regarding the delegation of work.
Sounds like a great idea.
Okay, so I'll set up I'll do an email after this call just to outline the situation with Daryl, and we'll see if we can get something organized that will some kind of collaboration organized. Philip, are you interested in being in on that? Since I know you're pretty interested in the overall code gen design.
Not sure if I'll be able to contribute, but I can try.
Okay, well, I'll CC you on it, and then you can follow along at the very least, because at some point somebody's going to care about the Z and P code gens, I would imagine, so we probably don't want to do anything that's going to paint us into a corner.
All right, so I think that's covered control, linkage, and J profiling. What else? We talked a little bit about upcoming work on generifying, expanding to other architectures, and possibly generifying from a runtime perspective and moving into OMR. I'm just trying to think if there's anything else on future work that is already published or publicly available that we can talk about in a publicly recorded call. And I can't think of anything right now, but if there's any ideas that people have for things they'd like to see in MicroJIT or things that they think we may have missed or overlooked, feel free to bring them up at this meeting or future community calls, or send me an email. Also, you'll probably hear a lot more from me on the Slack channels and so on and so forth over the next coming little while. I just finished up that course I was teaching. 5 weeks is an incredibly short amount of time to do an computer architecture and organization course. I don't know how they planned that originally, or how people have been doing that so efficiently, but it was a lot of work, a lot of 10 and 12-hour days.
Okay, yeah, it would be great to have some more discussions on the Slack channel. I know that most of the people that are interested are monitoring it. So I think you've covered all the major areas of integration that we'd identified, and there's some things there. I think most of there are 2 takeaways on me, which I'll deal with shortly after this call if I can. I guess if you don't have other things to discuss, I'll just pause for a moment and allow anyone else on the call who has questions or wants to comment or anything related to MicroJIT. Now is an opportunity to do so, since I think we've gotten through the core business items.
One of the other platforms we've been looking at is RISC-V. And we've been looking at bringing up the JVM in that environment. Cheng on the call has been leading that work. And one of the things we've been wondering is, I know MicroJIT is still a work in progress, but wondering how far from having the set of bytecodes complete. Wondering how far from being able to compile a reasonable set of the bytecodes MicroJIT is, and if it would be an interesting target to then take that and port it to RISC-V before porting the rest of Testarossa as a ability to get a JIT compiler up and running early in that environment.
So that's a great question. We're right now, and Harpreet can correct me because I think she was the last person to update this number, but I think we're around 65 or 70% of the bytecodes are covered. Right now, the big things that are used fairly often that we don't have coverage on are invoke virtual and invoke interface. And if I remember correctly from the previous meeting, Andrew mentioned that in a lot of more code that's been kind of compiled since Java 8, there's a lot more invoke dynamics now than there used to be. And invoke dynamic is obviously a very big bytecode to implement, both in terms of what it will allow us to do and also in terms of how much work it's going to be to implement it. So we've been kind of going from using two metrics to determine which bytecode to work on next. One is how easy it is to implement. So if there's a bytecode very similar to it, like for the compare instructions and the different branching instructions, once we had one done, it was pretty easy to do most of the others. And the other metric was how frequently it pops up. So the invoke method, the invoke bytecodes are all fairly high on the list of to-dos. So in short, we've got a decent coverage. Well over half of the bytecodes can now be compiled. And I think looking at the DeCapo benchmarks, if I was to go back, I think invoke interface and invoke virtual are the two big things that are preventing a lot of methods from being compiled. So when we get those working, we should see a decent number of methods as a percentage of some known benchmark applications that will be compilable. Also, I believe that both ARM64 and RISC-V were identified as areas we wanted to look at expanding into after AMD64.
Okay, so this is already something you're considering and thinking about porting to in the future. So I'm glad to hear that. There may be opportunities to work. Sorry, Cheng, I'm going to speak for you and put you on the spot. There may be opportunities to pull Cheng in to help coordinate around the RISC-V port. Either with getting started on the platform and possibly even with the changes to the changes required to do the port.
Yeah, I'm happy to do that.
So.
Awesome, that's great to hear. So depending on how we slice it up, I imagine you'll be speaking with myself or Harpreet a lot over the next while. Once we get x86 into a state where it's usable and also a decent thing for testing various research projects on. I think one of the things we were looking at for a future research area was which optimizations are essentially worth it, even in a templated compiler that's really gunning for fast compile times. Like, are there optimizations that are so tiny on the compile side, but have a large impact on the runtime side once the code is compiled and you're executing it? Are there some small optimizations that are worth it and will get us to warm up to TR's cold compilations even faster? And the trade-off there for different optimizations. So if there's anyone here who spends a lot of time on the optimization side, I imagine whichever one of us is coordinating with Chen, the other one's going to be talking with them sometime in the winter or summer.
Okay, cool.
Yeah, I would just put out there as well, though, that I think one of the areas in the bytecode that may be one of the harder ones to deal with, which is going to be needed for Java 11 and current release, will be the invoke dynamic. I don't think a lot of looking has been done at invoke dynamic and how it fits in with the template paradigm, or even how to connect the template generated code to the VM side of the implementation, since there's a fair amount of coupling. I think some of the rework that's happening at the moment, which is like Lacoon and Babinit Singh and Jack Liu and Nazim, is going to make that a bit simpler. There's some of the some things have simplified with the changes that are being planned there, but I think there's quite a lot to look at in that area before the bytecode implementation is kind of there. I certainly agree that you've got your coverage has increased quite a lot, and there's quite a lot of things that are a little bit more turning the crank. But I think the invoke dynamic may have some interesting challenges around it that are worth exploring a bit sooner rather than later.
Yeah, I remember a while ago attending a few talks and a thesis defense for someone who was working on invoke dynamic. They were doing method handle graph optimizations. And it seemed very complicated and in-depth for an individual bytecode. And every reference we've had or discussion we've had when invoke dynamic comes up has been kind of dismissed as, yeah, that thing's going to take forever and someone's whole degree is going to be about that probably. But if there is some simplification going on that end, and it can be made easier to integrate with, and the barrier is not too steep, it might be something that could become part of any one of the current students' work. So I'd like to be kept in the loop on that if possible, because that seems like a pretty important step for especially any of the newer versions of Java. As you said before, invoke dynamic becoming more popular means that support for it becomes more important.
Yeah, I think there's going to be some pull requests opening shortly. So once those have opened, I'll make sure to add them to the agenda for these meetings, just so that we can call them out if since that's an area of interest. And I think that's going to be important for getting to the point where the MicroJIT is capable of running anything newer than Java 8 with any reliability.
I would say that even without invoke dynamic support, it's still of interest on platforms like RISC-V, given the lack of JIT there, the entire lack of JIT there, that having anything is much better than having nothing. So
I think that's a great point, Dan. Yeah, that's very true.
We do have
I just worry about how much is actually going to get JITted, given how common the bytecode is becoming in something like 15 or 16. But you'll get something, so it's probably better than nothing. Yeah, I agree.
So I would also like to point out for Dan there that we have a paper in CASCON coming up, specifically talking about the gains that we got on x86 with MicroJIT, comparing it to interpreter only. So I can maybe even give you an idea. Obviously, there's going to be differences between architecture, and it's not all going to transfer one-to-one. Even the ratios are going to be off. But there might be some insights there to be gained, and some discussion you could probably have there with one of our exiting students, Eric Coffin, about how efficient MicroJIT is in an interpreted-only space with resource-constrained environment. I think he's using an Intel board that only had like 2 gigs of RAM or 1 gig of RAM, and some other things that were limiting it. And it was fairly low clock speed, low core count, that kind of thing.
Okay. Yeah, I'd love to see a copy of that paper.
Yeah, we did get accepted. I think a camera-ready one is coming out soon. At yesterday's weekly meeting with Marius, I believe he was working on some comments and addressing some comments from reviewers. But whenever the publication for the CASCON proceedings goes out, I'll be able to provide you a link to that paper. So, well, since you're IBM internal, I can probably maybe send an email to Eric CCU asking for a current version of the paper, just to kind of get maybe get your feet wet looking at some of what we got out of that.
Yeah, I'd appreciate that. If, you know, I could wait if I need to, but if I can get it early, that would be great.
Awesome.
Yeah, I think it would be very interesting if I think you said his name was Eric, was willing to maybe just give a short summary in sort of 10 or 15 minutes at the start of a MicroJIT meeting sometime in the next few weeks. I think that would be of great interest to everybody here, just to understand the value proposition of this contribution, because we all believe that it's useful, but having it quantified would be very interesting.
Sure, I can see if he's free. I know at this point in time he's working full time at a startup while he's finishing off his thesis and editing his paper. So I don't know what his schedule is like, but I'll see if he's interested in coming to one of these and giving a talk. If not, I'm very familiar with it. Like we started on the project roughly the same time, so I'm very familiar with the paper and with the contribution. So I can give an introduction to it as well once I get a current copy of the paper.
Sure. I'll leave it up to you guys to decide how you want to present it. But I just I think given like there will be a set of people who are interested in the paper and like going through all the details. But for people who are sort of more peripherally involved in this, just having that summary might be helpful, just to help make sure we keep the motivation for doing this, and we see call out the value to the community.
Agreed. And I hope he's available. He's available. I really hope he's available. It would be amazing to have that talk. Actually, that would get it out here in the open during the community meeting.
Yeah, that would be great. Okay, I'll leave it with you to discuss, and you can let me know when you guys are wanting to do that. It's just when I post the agenda or whatever, you can let us know that you'd like a little bit of time for it. I don't see any problem slotting it in on any given week, so if you just let us know when, that would be fine.
Awesome. Thank you very much.
Okay. Any other items that anybody would like to raise? Okay. Well, I guess since it sounds like we've concluded all the business for today, we've got a couple of takeaways. So thank you to everybody for attending. I'll end the recording now, and we can continue discussion on the Slack channel and in the issue as always. Thank you everyone for your time and your interest, and look forward to seeing everybody continuing to contribute on this project, because it looks pretty exciting to me. Thank you.
Thank you very much, Andrew. Thank you for coming, everybody.
Thanks.